Welcome back to the deep dive. Today feels, I don't know, a little different. Usually when we get behind these microphones, we're talking about building things, right?
Yeah, absolutely. Building is the fun part.
Right. We talk about the excitement of starting a project or the chaos of gathering data, the thrill of training a massive brain in a box. It's creative, it's energetic.
It is. It's that optimism phase of AI. Everyone is running on caffeine and hope.
Exactly. Caffeine and hope. But today we are staring into the abyss. We are tackling Phase V. And honestly, looking at this material, Phase V feels like that specific moment in every horror movie.
Oh, I know the one.
You know the one, right? The protagonist has finally shot the monster. The creature is lying on the ground. It's motionless. The music swells into something triumphant. And the hero turns their back to hug their friends, thinking it's all over.
And that is exactly when the monster's hand twitches.
Yes, that is Phase V. The monster is not dead yet. Phase V is model evaluation, and you are absolutely right about the tension here. Think about it. In phases I through 5E, the team has been grinding. They've burned through the budget. They've cleaned terabytes of just messy, awful data. They've spent weeks tuning hyperparameters until their eyes cross. They are exhausted, but they are high-fiving because the code actually runs.
And that confidence right there. That confidence is the killer.
Oh, wait, why is confidence dangerous here? I mean, we want a confident team, don't we?
In Phase V, no. Confidence is a liability. Because Phase V doesn't care about your effort. It doesn't care how late you stayed up fixing the Python script or how brilliant your team is. Phase V is about cold, hard verification against a contract that you signed months ago back in Phase I. It is the moment where you find out if you actually build what you promised or if you just built something that looks cool.
Wow, that is a chilling way to put it. It's the audit.
It is the receipt.
Yeah.
And the receipt does not lie.
Okay, so to get us through this audit, we're going to do something a little different today. We aren't just going to chat about the theory and the abstract. We are going to simulate the pressure.
We're role-playing.
We are. I'm going to be the tempted project manager. I've got deadlines. I've got a boss breathing down my neck, and I just want this project to pass. I want to ship it. You are the ironclad AI expert. You are the guardian of the allowed source.
And we should clarify that allowed source rule immediately because it is the most common way people fail this deep dive.
Yeah, break it down for us. What are the rules of engagement here?
We are in a sealed bubble. The source material for this discussion is strictly the PMI CPMAI V7 Phase V structure and the study commentary. That means no outside logic. I don't care how Google does it. I don't care how your cousin's crypto startup evaluates their bots. If it's not in the source text, it doesn't exist.
So if common sense contradicts the source
wins. Every single time. Because the exam isn't testing your common sense. It's testing your adherence to the framework.
Got it. So, listener, here is the game plan for you. We are going to break Phase V down into its 4 critical tasks. It's a single task group containing 4 specific tasks. I am going to give our expert a scenario, a real exam-style trap. I'll give you the options, then I'm going to say, take a moment.
And that is your cue, listener, to actually pick an answer. Don't just wait for us to tell you. Commit to it in your head. Because when we reveal the answer, we're going to tear apart why you might have been wrong.
And trust me, some of these are really tricky. We're covering model performance results, KPI measurement, the model iteration approach, and the review process. And a quick ground rule, everything here is rated critical.
Right. There is no filler in Phase V. Every task is a kill switch for the project.
Okay, let's unpack this. We're starting with the moment the model finishes training. The code is done. The data scientists are wiping the sweat off their brows. Now we look at the numbers. This is segment 1, model performance results.
This is the first hurdle.
Are you ready for your first challenge?
Lay it on me.
Okay, let's walk into the trap. Challenge number 1. We call this the benchmark trap.
Oh, a classic. Maybe the most common mistake in the industry.
Here is the scenario. Picture this. We are at a mid-sized financial services firm. We've just wrapped up Phase 5V, meaning the model is fully trained. It is breathing. Back in Phase I, we defined our success criteria. Let's say we need a minimum sensitivity of 90% on fraudulent transactions.
Okay, 90% is the target on the wall. That means we catch 9 out of 10 fraudsters.
Exactly. So the data science lead walks into the room. They look tired but happy. They pull up the slide deck. The model has scored 91% accuracy.
Okay, so far so good.
But they don't stop there. They pull up a chart showing the industry average for similar financial models. The industry average is 85%. So they say, look, we didn't just pass. We are crushing the competition.
Yeah.
We are 6% above the industry standard. This is a slam dunk pass.
I can absolutely see why that feels like a win. Everyone likes to be better than the average.
Right. It feels like incredible validation. So the question is, what is the correct standard to evaluate this model? Option A, pass it because it is the best result the model produced and it beats the competition. Option B, pass or fail strictly based on the predefined success criteria from Phase I. Or option C, pass it because it beats the industry benchmark. Listener, take a moment. You're the PM. Your team is cheering. You beat the industry. Do you sign off?
Your answer.
All right, expert, burst my bubble.
The answer is option B. You evaluate strictly against the predefined success criteria established in Phase I.
Hang on. I have to push back here. If everyone else in the banking industry is getting 85% and I'm getting 91%, I have a superior product, why in the world would I ignore that context? That sounds like bad business. It sounds like I'm ignoring reality.
It sounds like good business, but it's bad governance. And it's a failure of project management logic.
Explain that to me.
Think about what Phase I actually is. Phase I is a contract. You sat down with the business stakeholders, the people paying the bills, and you said, to solve this specific problem for this specific company, we need X performance. You didn't say we need to be better than JP Morgan. You said we need 90% sensitivity to stop us from losing $10 million a year.
Okay, so the specific internal need trumps the external comparison.
Exactly. Because if you look at benchmarks, you're bringing in outside variables that you didn't control for. Maybe the industry average is lower because they're using cheaper data. Maybe they're solving a slightly different problem. If you start grading yourself on a curve, you are moving the goalposts just because you kicked the ball far enough.
Wow, that is a great line. Moving the goalpost because you kicked the ball far enough.
And let's look at the other trap in there, option A, pass, because it's the best result the model produced.
Yeah, that's the best run theory. If I train the model 10 times and the best one was 91%, isn't that my score?
That's circular logic. You cannot judge a model based on its own output. If you do that, you're basically saying whatever the model is capable of doing is the definition of success.
So if the model is terrible, but its best terrible run was 50%, and I use the best run logic,
then 50% becomes your passing grade. You see the problem. You need an external immutable standard. That standard was carved in stone in Phase I. You don't get to chip away at the stone just because the model is struggling or succeeding.
So the memory hook here is Phase I set the bar. Phase V finds out if the model clears it, the bar doesn't move.
Precisely. If Phase I said 95% and the industry average is 90% and you hit 91%, you failed. Period.
Brutal. Okay, let's keep the pressure on.
Yeah.
We are still in model performance results, but now we're dealing with a human element. This is challenge number 2, the calibration trap.
The human element is usually where the trouble starts.
Scenario. You are in a healthcare organization. High stakes. This isn't just money. This is patient health. Phase I required 94% sensitivity on a critical class. Let's say detecting a specific rare disease.
94%.
Yeah.
That is a very high bar, but necessary for healthcare.
The model finishes Phase 4 training. It hits 91.5% sensitivity. It's close. It's so close. And the overall accuracy, how often it's right in general, is really high. So the clinical lead and expert doctor says, look, 91.5% is practically 92%, which is close enough. The overall accuracy is great. Let's just adjust the threshold in the document to 91% so we can pass this and move on. It works well enough.
Just adjust the threshold. Famous last words.
Here are your options. Option A, accept the adjustment because the overall accuracy supports it and the expert says it's safe. Option B, decline the adjustment because criteria changes need governance reapproval. Option C, decline and immediately document a no-go in the review process. Listener, take a moment.
Do you adjust?
Adjust, decline and govern, or decline and kill it.
Lock it in.
All right, reveal the truth.
The correct answer is option B. Do you decline the adjustment? Changes to predefined success criteria require governance reapproval. They cannot be adjusted at team discretion.
Even if the clinical lead, the subject matter expert, says it's okay.
Even then, the clinical lead is a team member. They're not the governance board. What they're doing is called rationalization. They see the score. They like the score, so they want to rewrite the test so the score is a passing grade. That is cheating the test.
It's like shooting an arrow into a barn wall and then painting the bullseye around where it landed.
Exactly. And think about the risk. If you lower that sensitivity from 94% to 91%, you are accepting more false negatives, more sick people being told they are healthy. That is a business and ethical decision that belongs to the governance board, not the project team, in a breathless meeting.
Yeah, I want to talk about option C. That was decline and immediately document a no-go. Why is that wrong? It sounds rigorous. If we failed, we failed.
Because of sequencing. This is a huge part of the exam logic. You don't jump straight to the review process, which is the final gate, just because you failed to check. If you fail, You have to follow the fail path. That means you go to the model iteration approach first. You need to analyze why you failed before you go to the gatekeeper.
Ah, so option C is the jumping the gun trap. You can't just quit. You have to figure out the next step first.
Correct. But the core lesson here is about the contract. The threshold is a contract. Rewriting the contract because you're losing isn't agile. It's a governance failure.
Okay, so we've established that technical performance is a strict pass-fail against Phase I. No fudging the numbers. No industry average excuses. Now let's assume the model actually passes. It hits the 94%. We're done right. Champagne time.
Not even close. You have only answered the question, is the model right? You haven't answered the question, is the business winning?
This brings us to segment 2 KPI measurement.
This is the most overlooked task in the entire stack. Technical teams love to skip this.
Let's look at challenge number 1 for this segment. We call it the missing step.
Okay.
Scenario, a fraud detection model. It passes all the Phase I technical criteria. Accuracy, recall, precision, all green. The sponsor is excited. They say ship it. But 6 weeks later, the actual fraud rate in the company hasn't moved. It's flat. We were losing just as much money as we were before.
A nightmare. The Operation Successful Patient Died scenario.
The question is, what happened? What task was likely skipped? Option A, they used a bad holdout test set in Phase 4. Option B, they skipped KPI measurement in Phase V. Option C, the training log was incomplete. Listener, take a moment. What went wrong?
Have your answer ready.
What's the verdict?
The answer is option B. They skipped KPI measurement.
Okay, explain the difference to me. If the model is accurate, if it's identifying fraud correctly, how can the fraud rate not move? That seems impossible.
It happens all the time. This is the gap between model performance and KPI measurement. Model performance measures the algorithm. Does it predict fraud correctly on a data set? Yes. But KPI measurement measures the outcome. Does using that prediction actually stop fraud in the real world?
Give me a concrete example of how that disconnect happens.
Imagine the model predicts fraud perfectly. 100% accuracy. It sends an alert. But where does that alert go? Maybe it goes to an email inbox that nobody checks until Monday morning. By the time the analyst sees it, the money's gone.
Oh, wow. So the math was right, but the process was broken.
Exactly. Or maybe the alert is too complex, and the call center agents don't understand what to do with it, so they just ignore it. The model passed. It did its job.
Yeah.
But the business process failed to use the model to change the KPI. If you skip KPI measurement, you don't catch that implementation gap until you've already launched and failed.
That is a crucial distinction. Model performance is the math right.
Yeah.
KPI measurement is does it work?
Exactly. And notice option A, the bad holdout set. That is a Phase 4V problem.
Wow.
If you were in Phase V, you assume Phase 5 was done correctly. The specific failure of technically good but business bad is a KPI measurement failure.
Okay, let's deepen this. Challenge number 2 in KPI measurement, direction versus destination. This catches so many people.
This one is tricky. It appeals to our desire for progress.
Scenario, a logistics company. Phase I target, reduce lead deliveries by 15%.
A clear quantified target, 15%.
The model passes technical checks. They run a pilot. The data shows an 11% reduction in late deliveries.
Okay, so we are saving money. Customers are happier.
The data science lead says, hey, 11% is a meaningful improvement. We're moving the needle. It's a win. Let's go.
It sounds tempting. 11% is definitely better than 0%.
Options. Option A, pass because the trend is positive and confirms business value. Option B, fail and apply the model iteration approach. Option C, pass but update the target to 11%. Listener, take a moment. Is 11% pass?
Make your choice.
Reveal the hard truth.
The answer is option B, fail, and apply the model iteration approach.
You're failing a project that saved the company 11% on late deliveries. You are a harsh project manager. Why?
I am a governed project manager.
Right.
The source truth is directional improvement. 11% is not criteria compliance, 15%.
But isn't some improvement better than nothing? Why punish the team for an 11% win?
In the real world, outside of this framework, maybe you ship it. But within the logic of the exam and rigorous project management, no. Phase I define the destination. We need 15% to make the ROI make sense. If you hit 11%, you missed the target.
So what's the harm in option A? Just saying it's good enough?
The good enough trap is dangerous because it hides the gap. If you pass it at 11%, nobody asks, why didn't we hit 15%? Maybe the model is suboptimal. Maybe the integration is laggy. If you fail it, you trigger the model iteration approach, which forces you to find out why you missed. Maybe you fix it and hit 15%. If you just pass it, you leave that value on the table.
So moving in the right direction is not reaching the destination. Phase I define the destination.
Correct. Model performance results asks, did the model perform? KPI measurement asks, did the business move enough? A yes on the first doesn't mean a yes on the second.
Okay, so let's say we failed. We missed the 15% or the model accuracy tanked. We are now on what the outline calls the fail path.
The fail path is an exam content outline hotspot. You need to slow down here. This is where the methodology saves you from absolute chaos.
This brings us to segment 3, model iteration approach.
This is where things get messy in real life. Everyone starts pointing fingers.
Challenge number 1, the obvious fix.
Obvious is usually a trap.
Scenario. Phase V fails. The data science lead looks at the failure and says, oh, I know exactly what this is. It's the labeling gaps in Phase 3. I told them the labels were messy. Let's go fix it right now.
Action-oriented, I like their energy. They want to fix it.
Options. Option A, go to Phase 3 immediately to fix the labels. Option B, complete the review process, no go first. Option C, complete the model iteration approach first. Listener, take a moment. Do you fix it, document the failure, or analyze the failure?
Think about the methodology.
What's the move?
The answer is option C, complete the model iteration approach.
But why, if they know it's Phase 3, isn't documenting it just bureaucracy? It feels like filling out forms while the house is burning.
It feels like bureaucracy, but it's actually root cause analysis. The source defines the model iteration approach as a structured, documented root cause analysis, identifying which phase to return to.
Why does that matter?
Because what if the data science lead is guessing? What if they think it's Phase 3 because they hate the labeling team, but it's actually a Phase 2 data collection bias? If you jump straight to Phase 3 option A, you start reworking. You spend 2 weeks relabeling data. Then you retrain in Phase 4. And then you fail again.
Because you didn't fix the real problem.
Exactly. The model iteration approach turns a guess into a documented decision. It forces you to prove the root cause before you burn more budget.
And what about option B? Why not do the review process first? That's the no-go decision, right?
This is a sequencing rule. On the fail path, model iteration approach precedes the review process. Think about it. The review process authorizes the next step. If you haven't done the analysis, you don't know what the next step is. You can't authorize a plan you haven't written.
That makes total sense. You need the iteration approach before you can sign the review process.
Exactly. Everyone has an opinion about which phase caused the failure. The model iteration approach makes it a documented decision instead of a guess.
Okay, now let's talk about a specific type of failure. This is one of the trickiest concepts in Phase V. Challenge number 2, the drift trap.
Drift is a huge topic, and the exam loves to trick people who know just enough coding to be dangerous.
Here's the setup. You have a claims routing model. It passed all the initial checks. You put it into a 2-week pilot. At the start, accuracy was 91%. 2 weeks later, it drops to 78%.
That is a massive drop, a free fall.
Here is the smoking gun. No code was changed, no hyperparameters were touched. The model is bit for bit identical to the one that scored 91%.
Okay.
The data science lead calls it a tuning issue. They say it needs tuning. Let's go back to Phase 4 and retrain it.
The reflex to retrain is the turn it off and on again of AI.
Options. Option A, retrain in Phase 4. Option B, apply model iteration approach to check Phase 2 or 3. Option C, treat it as a Phase 5 operational issue. Listener, take a moment. Where do you go when performance drops but the code didn't change?
Lock in your answer.
Reveal the answer.
Answer is option B. Apply the model iteration approach. Do not assume Phase 4.
Why not Phase 4? Retraining fixes performance, right? That's what we do in Phase 4.
Not if the problem is data drift or model drift. If the code didn't change but the results did, it means the world moved. The incoming data is different from what you trained on.
So retraining the same model on the old data won't fix it.
Exactly. Think of it like a map. You built a map of the city in 2019. It works great. Then 2020 comes along, roads close, and new highways open. Your map stops working.
Right.
If you go back to Phase 3, which is just drawing the map again, and you draw the map based on the 2019 survey data again, what do you get?
The same broken map.
Exactly. You get the exact same failure. To fix drift, you have to go back further. You have to go to Phase 2 data collection to get new data that matches the new world, or Phase 3 data prep to label it differently.
That is a profound distinction. The model didn't break. The world moved. Phase 4 didn't cause that, and Phase 4 can't fix it.
That's the memory hook. And to address option C, why isn't this Phase 6? Because we are still in the pilot. The pilot is part of Phase V evaluation. If drift happens during the pilot, it's a Phase V concern, not an operational bug.
Got it. So drift triggers the model iteration approach to figure out if we need new data Phase 2 or new labels Phase 3 rather than just blindly turning knobs in Phase 4.
Precisely. The model iteration approach answers where do we go and why. The review process answers are we authorize to move. You need the first to complete the second on the fail path.
Okay, we've analyzed the results, we've checked the KPIs, we've maybe even analyzed a failure. Now we reach the final gate, segment 4 review process.
The bridge to the real world, or the wall that stops you.
Challenge number 1, the email gate.
This happens all the time in the real world.
Scenario. Both technical and KPI tasks pass. Everything is green. The team agrees in the stand-up meeting. The project manager, me, the tempted PM, sends an enthusiastic congratulations email to the stakeholders. Great results. We are starting Phase V as deployment next week. But then a compliance review asks for documented Phase V authorization. What does the PM find?
It feels like momentum. It feels agile to just send an email.
Options. Option A, this is fine as long as the metrics are archived somewhere. Option B, this is a governance failure. You missed the review process. Option C, this is fine. The email counts as documentation. Listener, take a moment. Is an email a gate?
Got it.
Verdict.
Option B, governance failure. The PM finds absolutely nothing because an email is not a gate.
Why? An email is written, it's documented, I can search for it in Outlook.
An email is communication. It is not a governance artifact. The review process is the formal Phase V gate. It's a documented go or no-go decision with rationale.
That's the difference, really.
Imagine 6 months later, an auditor comes in. Or the model fails catastrophically and gets the company sued. They ask who authorized this. You pull up an email chain with emojis and reply alls. That's not authorization. That's chatter. Informal agreement is not a governance artifact.
You need a signature.
You need a formal sign-off document that says we reviewed X, Y, and Z, and we decided to proceed because of reasons A, B, and C. It creates accountability.
So the team's confidence is not a governance record. The documented decision is.
Exactly. You cannot replace a formal gate with a vibe check.
Okay, final challenge. Challenge number 2. The sequencing trap.
We touched on this, but let's really nail it down.
Scenario. Evaluation fails. We have a fail result. Stakeholder A says, let's complete the review process first. Document the no-go, then we can figure out the iteration plan. Stakeholder B says, no, apply the model iteration approach first. Figure out the plan, then complete the review process.
Gate first or plan first?
Options. Option A, listen to stakeholder A, gate first. Option B, listen to stakeholder B, analysis first. Listener, take a moment. Who is right?
Make your choice.
Who is right?
Stakeholder B, analysis first.
Explain the logic one more time.
It comes down to what the review process is. It's a decision point. It's an authorization. If you do the review process first, all you can say is we failed. You can't authorize the next step because you don't know what it is.
Right. It's an empty meeting.
If you do the model iteration approach first, you come to the review meeting and say we failed. The root cause is Phase 3 labeling. We recommend returning to Phase 3 to relabel 5,000 records. The review process then authorizes that return. Root cause and return phase identification must be documented before the gate is formal.
So the pass path is performance, then KPI, then review, then Phase 6. But the fail path is performance fail, then model iteration approach, then review, then return to previous phase.
You got it. You need to know where you're going before you can open the gate to go there.
This has been intense. I feel like I've just survived an audit.
It's supposed to be. Phase V is critical. It's the firewall between development and production.
Let's wrap this up with a summary of the 4 tasks we just survived.
Sure. Task 1, model performance results. Stick to the Phase I contract. No benchmarks, no best run, no adjusting the threshold because you're close. Task 2, KPI measurement. Direction is not destination. Technical success does not equal business success. You must measure the outcome. Task 3, model iteration approach. Don't guess. Document the root cause. And if it's drift, remember the world moved. So don't just retrain in Phase 4. Task 4, review process. It's a formal gate, not an email. And on the fail path, do your analysis before you sign the decision.
Trust the source, trust the sequence.
That is the absolute mantra.
I want to leave you, the listener, with a final provocative thought. We talked about the nightmare of the model passing technicals but failing KPIs.
The Operation Successful Patient Died scenario.
Exactly. If that happens, if your model is 99% accurate but the business KPI doesn't move, that forces a really hard question. It's not, did we build the model wrong?
No. The question is, was our Phase I business theory wrong from the start?
Did we solve the wrong problem? Did we spend 6 months building a perfect tool for a job that didn't need doing? Phase V is where you find out if your whole hypothesis was flawed, and that is why it's so scary.
And why it's so important to do it right. Because finding that out in Phase V is painful. Finding it out in Phase X, when real customers are impacted, is catastrophic.
Huge thanks for keeping us on the straight and narrow today. Good luck with your study session, everyone.
Good luck. Stick to the allowed source.
See you in the next deep dive.